Hello, dear students. My name is Shahid Mahmood. Today I will explain the answers of the alkanes topic question of section B in a quick and easy way. So let's start with the question. Question number one. Heptane is one of the compounds present in crude oil. When heptane is reformed, the products include 2,2,3 trimethyl and cyclopentane. Give a reason why petrol should not contain high proportion of heptane. Heptane is a long chain hydrocarbon. There are 7 carbon in the chain. So any fuel or any petrol which having a large number of the straight chain alkane will not be a good quality fuel. So when there is high proportion of heptane in the petrol or in the fuel, so it will not burn efficiently. So you can say the petrol will does not burn efficiently. The second reason is if there is a high proportion of heptane or the straight chain alkane in petrol, so it will cause more knocking. So will produce more knocking. Or you can also say it will decrease the octane number of the fuel. Part 2, draw the skeletal formula of 2,2,3 trimethyl butane. Whenever you are given the name and they are asking to draw the structure, so always start from the stem name, that is butane. So first of all, you should draw 4 carbon. This is butane. Now, give numbers from any side, you can give the number. So there are 4 carbon. Now, the branches. At 3 position, there are 3 branches. So one methyl group is attached at second position, another is also at second position, and one is attached at third position. So this is the structure of 2,2,3 trimethyl butane. Part 3, write the equation for reforming heptane into cycloheptane. Use molecular formula. State symbols are not required. Now they are asking here, they given bold molecular formula. So the heptane molecular formula is C7 and H16 hydrogen will be 2 more than double. Now this is reforming. So into cycloheptane, and the alkene general formula are same. So hydrogen will be double 2 carbon and 1 hydrogen has been removed. Whenever the straight chain alkane change into cycloalkane, 1 hydrogen is always removed. When petrol is burned in a car engine, oxides of nitrogen are formed. Explain how these compounds result in damage to trees. It's a simple idea, like one is oxides of nitrogen and one is oxides of sulfur. They produced when we burn the fossil fuels in the car engines or in the factories, they produce these oxides of nitrogen and oxides of sulfur. They mix with the water and they cause acid rain. So here simply you can say that nitrogen oxides they're already giving us oxides of nitrogen. So you can write for the first mark that oxides of nitrogen will react with water, will react with water, first mark, and the second mark you can say and will produce acid rain. So for 2 marks, you can simply write like this: oxides of nitrogen react with water vapors, react with water, and then to produce acid rain, which will damage the trees. Part B, heptane reacts with chlorine and sunlight. Chlorine radicals are formed in the first step in the mechanism. Now, name this step in the mechanism. Whenever chlorine reacts with alkane, always the first step is in which the free radicals are produced is called initiation step. So the name of the first step in which the free radicals are formed, initiation step. Part 2 gave two propagation steps for the formation of chloroheptane. In this case, they're asking two propagation steps. My dear students, listen very carefully. Chlorine free radicals which are produced are highly reactive. Heptane, which is alkane, and alkanes are called unreactive. They are saturated because they have single bonds in which each carbon is bonded to four other atoms. So it doesn't react that much. But in this case, C7H16, which is unreactive or least reactive, but it is now facing chlorine free radical, which is highly reactive. This chlorine will take by force, it will snatch one hydrogen and it will give HCl. Now, what will left behind here? So C7 and H15, but you will just put a dot on carbon free radical, peptide free radical. This is the first equation. And the second equation, that C7H15, which is a free radical, so it will come from this step now. Now it is more reactive because it's a free radical. It will react with normal chlorine, molecular chlorine. This time this is more reactive, so it will snatch one chlorine from here and we will get C7H15Cl and plus. From here one chlorine is snatched by heptyl free radical and one chlorine will not go ahead. So these are the two easy steps for the formation of chloroheptane. Now here they are asking that give the termination step which forms a hydrocarbon. You saw in the propagation step that C7H15 was the free radical, heptyl free radical. So there is a probability that two heptyl free radical will combine and we will get a hydrocarbon with double number of carbon atom and even double number of hydrogen. So this will form. Part 4, explain how some dichloroheptane also forms during this reaction. Explain how some dichloroheptane also forms during this reaction. So see here, the equation which we just wrote before, see here, I will quickly write to recall you, C7H16 and plus chlorine free radical, the propagation step I'm writing again. So C7, sorry, H15 free radical plus HCl form. Then C7 and H15 free radical react with chlorine molecule and we get C7H15Cl and plus chlorine free radical. Now, this is only chloroheptane form. They are asking now dichloroheptane. So when you continue this, so you can say that this C7H15Cl and this free radical, like me, both these products will come for the next step. Again, chlorine is more reactive. It will snatch hydrogen to become HCl and plus what will left behind. So C7H14 and Cl dot will form. This C7H14Cl free radical will react now with neutral chlorine, molecular chlorine. It will snatch one chlorine from here to give stable product. So C7H14 and Cl2 plus Cl dot. So these two equations are the answer for this question. But you write this equation and this equation for 2 marks, and you can write also in words. So in words, how you will write this? Chlorine free radical remove this chlorine free radical remove one more hydrogen from C7H15Cl. This one, see this chlorine free radical will remove one more hydrogen from C7H15Cl like this. Definitely a free radical will form. And that free radical, like this free radical which came from here, this free radical, or the second one, reacts with Cl2 here, with Cl2, to form C7H14Cl2 dichloroheptane. So you can write for this answer these two equations or simply describe these two equations for 2 marks. Because in every two equation, one hydrogen is replaced by chlorine. Question number 2, again heptane is an alkane found in crude oil. Heptane can undergo incomplete combustion. Give a reason why incomplete combustion sometimes occur. So this is due to limited supply of oxygen. This is the main reason if oxygen supply is not enough. If oxygen is not sufficient, if oxygen is limited, if oxygen is not sufficient, if oxygen is not enough, so for 1 mark, you can write any one of it. Write the equation for the incomplete combustion of heptane forming carbon monoxide in water, the only product. So they made it very easy. So you can say C7H16. Now this is incomplete combustion. Combustion means burning in air, burning in oxygen. So lazim plus 1, 2 plus O2. And now we will get only carbon monoxide in water. Now we have to balance the equation, state symbols are needed. Carbon 7, so 7. Hydrogen 16, so make it 8. Now 8 times 2, 16. Let's come to oxygen. So this is 7 and this is 8. So total oxygen on the product side is 15. You can write here 7.5. You can write this also. So this is the balance equation. Or you can write in this way that if this side is 15 oxygen, so write here this number 15 here. So 15 times 2, 30. Here is 15 oxygen. This side is 30. So divide by 2. So it become also 15. So to write the equation for the combustion reaction is a bit easy question. So you should try your best to get full marks. Part B, heptane is reformed into branched chain and cyclic hydrocarbon that are used in petrol. Draw the skeletal formulae of a branched chain alkane and a cycloalkane, each containing 7 carbon atoms. The first thing, the open chain, so it is branch chain, not single. So see here, there are total 7 carbon. So 1 carbon you can remove, 1, 2, 3, 4, 5, and then 6. 1 carbon you can remove as a branch. You can attach here, or you can attach it here, or you can attach it here. Anywhere you can attach that branch. So this will be the product. Or you can also say, like if you draw 5 carbon in the chain, 1, 2, 3, 4, 5. Now 2 carbon still we have. So you can attach one here and one here, or you can also attach one there and one. So this is the branched chain alkane. Now for the cycloalkane, you have number of options. I will suggest, suppose if you just draw one cycle, it will be a bit difficult for you. So 1, 2, 3, 4, 5, 6, and this 7. So it doesn't look that much nice. It will be more better if you, because this is a bit symmetrical hexane, this is cyclohexane, and now we need to draw 7 carbons, so just attach one is a branch. Much better. Similarly, you can draw cyclobutane, so 4 carbon in this, and you can attach one branch here, one branch here. No problem. You can draw cyclopropane with the 3 branches. So there are many options. Just draw only one structure and go to the next question. Because in the paper, if there is 1 mark question and you are confident about the answer, always write down that definite answer and then go to the next question. No need to write multiple answers. Write the equation for the reforming of heptane into cycloalkane and use the molecular formula. In this case, they are asking molecular formula. So C7H16 to cycloalkane. So C7H14 plus H2. I told you before that whenever the straight chain alkane change into cycloalkane, so always one hydrogen will be removed. Now, give a reason for adding cycloalkane to petrol. This is the same question, but in other way around. to the first one, like where they said that why we don't take high proportion of heptane into petrol. Now they are adding cycloalkane to petrol. So the best option is the petrol having the cyclo compound. Cycloalkanes or branched chain alkane will always burn. It will burn efficiently. This is the option, good option. So write down this, or you can also say, so it will prevent knocking. It will prevent pre-ignition. It will reduce the octane number. So there are many choices. You can write any one of it for single one. Heptane reacts with chlorine in the presence of ultraviolet radiation. State the type and mechanism of this reaction. Common question, and I always tell the student to learn this properly. Free radical. Alkane all reactions are free radical mechanism. This is the name of the mechanism, and substitution is the name of the reaction. So free radical, substitution, and reaction. Now, this is very solid question, like give the mechanism for the reaction to produce this chloroheptane and this hydrocarbon and HCl is the only products. Include name of each steps in your mechanism. Curly half arrows are not required. So see here, the first step is initiation step. Now, this is initiation and step. In the initiation step, is curly arrows are not required, so chlorine will change into free radical. Homolytic bond formation takes place. Please take care of these dots, okay? Because any species having unpaired electron is called free radical. Chlorine free radical always form in the first step, which is initiation step. Now, let's come to the second step, which is propagation step. We have to reach to this product. So see here, chlorine free radical is produced, which is highly reactive. Now, in the first equation of this chlorine free radical will react with this. This chlorine free radical is highly reactive. It will snatch one hydrogen to become HCl. What's left behind? So C7H15 and free radical. This free radical will come forward. C7H15 will now react with molecular chlorine. This is more reactive now. It will snatch one chlorine. Always the free radical will snatch an atom from the other party. So this is free radical, highly reactive. It will snatch one chlorine from here, and we will get the product C7H15Cl plus the remaining one will be again Cl dot. So these are the two steps of propagation. So my dear student, if you look at that question, so we are just according to that condition, like we get this product also, and we get HCl product also. Now we will just work for the last product, and that will happen in the third step, that is termination step. Now in termination step, number of reactions take place, but we will just only write the equation which will give us that product, and that is possible only and only when this free radical, so C7H15 free radical react with another C7H15 free radical, and we will get C14 and H30. Now you can easily divide the marks, the 7 marks, so 1, 2, 3, 4, 5, 6, and 7. So 7 marks, and in less time you can easily score, but after proper practice, you must be able to write the mechanism for any given alkane. Question 3, this question is about cycloalkane. When alkanes from the crude oil are reformed, the products include cycloalkane. It means cycloalkane or branched alkane are formed always in the reforming. Write the equation for reforming hexane into cyclohexane. Let me increase the size of this hexane into cyclohexane using skeletal formulae for the organic compound. So see here, 1, 2, 3, 4, 5, and 6. This is hexane. Now, we are going to change this straight chain into cyclo. As I told you, this is third time in this video. I'm telling you that when a straight chain alkane changes into cycloalkane, always hydrogen will be removed. Part B, the skeletal formulae of the cycloalkane D is shown. Give the name of the compound. So you will write the name in such a way to give number. So number you will give from that side that the branches should get the least number. You can start numbering from here also, from here also. Branches are attached at 1 and 3 positions. So this is 1, comma 3. Then dimethyl, and then the stem name cyclopentane. Give the molecular formula of D, this compound. There are total 7 carbons, see here, 5 in the cycle and 1 here and 1 here. So if carbon are 7, so hydrogen will be double of it. My dear student, keep in mind that for alkene and cycloalkane, they have same general formula, and that is CnH2n. It means in alkenes and in cycloalkanes, always the hydrogen number will be double to the carbon number. So if carbons are 7, hydrogen will be 14. In organic chemistry, always the questions are a bit mixed together. So sometimes like it is very difficult that a question belongs to only alkane. Definitely it will contain some calculations, or sometimes like it will contain some part of alkene, crude oil, polymers. I try my best to separate only the question which linked only to alkane in this video. Part C, there are 4 structural isomers of C6H12 with a ring of 4 carbon atoms, cyclobutane. One of these isomers is shown in the first box. Complete the skeletal formulae of the other 3 isomers. This is now about 6 carbons. So 1, 2, 3, 4, 5, 6. Now look at here. Here they are attached to the branches are attached to the attached carbon are 1 and 2 positions. So it is also possible that if you attach 1 carbon here, 1 methyl group here, 1 here. Now they are at which position? 1, 2, and 3. Okay. So 1 and 3 position. So here they were attached at 1, 2 position. Here they are attached at 1, 3 position. Here you can also say that they may attach to 1 position like 1, 1 dimethyl. And here in this case, we cannot change the position anymore. So it is better that if you attach ethyl group. So this is ethyl cyclobutane. So these are the 4 possible isomers. Now, in the next part, a cycloalkane E has a molar mass 126 gram per mole. Reduce the molecular formula of E. Now, if you look at the compound cycloalkane, like suppose I will take this example. Like look at here, if you draw this, I just want to give you the idea that you can implement in future for the new question. So look at here, each carbon is making 4 bonds. Each carbon is making 4 bonds. So in simple cycloalkane, each carbon is bonded to 2 hydrogen. So it is CH2, 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 and this is the sequence. Now they give us the molar mass and they are asking the molecular formula. So the best way or the easy way to reach to the answer is you will work out the question 126 divided by 14. 14 is the mass of carbon and 2 hydrogen. When you will divide this, so you will get 9. So the best option is C9 and then H hydrogen will be double and its MR is 126. Now, as I told you before in the start of this question, that means in alkane, definitely they will include some calculation parts and some alkene part and some crude oil and polymer parts in this question. They gave you the combustion equation. This is complete combustion. And the question is related to the calculation, which is topic 1. Now, a sample of gaseous cyclopentane with a volume 25 cm3. It means cyclopentane is given as 25 cm3. And it was mixed with 250 cm3 of oxygen. Now they help you, they give you an excess. It means oxygen is in more quantity while the limiting reagent is cyclopentane. It will totally combust it. and the mixture was ignited, only gaseous products are formed. Asking calculate the volume of each gas remaining after the reaction. All volumes, the gas volumes are measured at the same temperature and pressure. In such question, first we have to find out the limiting annexes, but they already made our problem solve that oxygen is annexes, so no need to look at here. Just we will focus on 25 cm cube of that. Look at here that first of all, we have to see that how much oxygen is used. Now, if you look at the question, so C5H10 ratio oxygen. This is given if this is 25 cm cube, so how much oxygen volume will be required? We will definitely use the ratio given in the equation. So this is 2 and this is 15. So cross multiply. So x is equal to 25 times 15 divided by 2. And we will get the answer 187.5 cm cube. Now oxygen is given as 250. So total is given 250, which was in excess minus 187.5, which is used up, which will react with 25 cm cube of cyclopentane. And the remaining volume will be 64.5 cm cube. So this is the amount of oxygen left unreacted. Now, you see here that 2 moles of C5H10, and this is the product side is carbon dioxide. So if this is 2, this should be 10. So this is combusting 25 cm cube. So it will be combusting how much? So you can again cross multiply 25 times 10 divided by 2, and you will get the answer 125 cm cube. And as in the product, 10 moles of carbon dioxide, the volume produced 125. So this is also 10 moles of water vapor. So the water vapor is also 125 cm cube. So we can easily reach to our answer. So always you will find out the volume of the products and even the remaining one from the limiting reactant, which is 25 cm cube cyclopentane. The next part, cyclobutane reacts with chlorine and sunlight. Name the mechanism and type of reaction that is occurring. Same question again, repeating question. So it is free radical substitution reaction. 1 mark for the free radical, 1 mark for the substitution reaction. Now in this question, complete the equation for the initiation step of this reaction mechanism, include appropriate curly arrows. So my dear student, here homolytic bond breaking will takes place. Always you will draw the arrow, you will originate the arrow from the center of the bond, and it will be curly half arrow. So one arrow will here and the other arrow will here, and you will get Cl dot plus Cl dot. Curly half arrow shows the transfer of one electron from the bond pair. The next part, write the equations for the two propagation steps to form chlorocyclobutane. Use C4H8 as a formula for cyclobutane. We have to write two equations, curly arrows and state symbols are not needed. So C4 and H8, as I told you before that from the initiation step, chlorine radical will come. Now it is more reactive, it will snatch one hydrogen, so it will become HCl plus. What will left behind, so this is C4H7, and always put a dot on carbon, free radical form. This C4H7, which is free radical now more reactive, will react with a molecular chlorine. This time this is more reactive, so it will snatch one chlorine from this reactant, and we will get C4H7Cl plus. From here, one chlorine is snatched by C4H7, so another free radical is. Now, these are the two equations of the propagation. In the next part, a small amount of hydrocarbon forms in this reaction. Deduce the skeletal formula of this hydrocarbon, justify your answer. Now, in this case, they are asking the skeletal formula and for the hydrocarbon. So this is cyclobutane. So this is one. This is another free radical. Both free radical will join together, and we will get the product, hydrocarbon product. This, like this and this, the free electron and this unpaired electron will make this single bond. So you can write that the two, what is the justification? The two cyclobutyl free radicals that is C4H7, this will join together, will react together, will join together to form the hydrocarbon or to form C8 and H14. Now, question number 4, the straight chain alkane hexane can be formed to give a range of products. Reform to give a range of products. It was suggested that one such reaction may produce a cyclic hydrocarbon and hydrogen gas. A is the only product. The cyclic hydrocarbon contains a ring of 5 carbons. Now, keep in mind it was hexane. It is giving cyclo compound but with 5 carbons. Write the equation for the reaction using the molecular formulae. State symbols are not required. So it is hexane. So C6 and hydrogen will be 2 more than double. And it will give cycloalkane. So one hydrogen will be definitely removed from here. So it will be 12 and H2. Now, draw the structure of the cyclic hydrocarbon formed in this reaction. So this, you will link it here. This thing you will link it here. Because they give a clear indication that the cyclic hydrocarbon contains ring of 5 carbon, but overall there are 6 carbon. So it's very simple. You will draw cyclopentane and just the 6th carbon you will attach as a branch. So very easily you can reach to your answer. Hexane will react with chlorine in the presence of ultraviolet light to form a number of products. Describe the role of the ultraviolet light in the initiation step of this reaction. So the UV light, UV rays provides the energy to break the bond of Cl2 homolytic and form two chlorine free radicals. The now the answer is enough here, but just to explain it, like this is chlorine bond. The chlorine atom size is bigger as compared to fluorine. Now, to break this bond, the energy required, it come from the UV light or sunlight, and the UV light or the sunlight energy is enough. It is more than the bond energy of this, so it can easily split the bond over here between the chlorine. It cannot split the bond between bromine and other, but like it can easily split the bond between the chlorine atom. Bromine also can react with that, but fluorine is a bit like stronger. The alkane dodecane is formed in this reaction. Write equations for the propagation step and for the termination step for the formation of this product. The product is dodecane. Use the molecular formula in your question. Now we have to start from the, because chlorine free radical is also produced in the initiation step. They're asking to do propagation and termination step. So C6 and H14 plus chlorine free radical from the initiation step. Again, I will repeat, please listen carefully, try to learn, and then practice on the questions. Chlorine free radical is highly reactive. It will snatch one hydrogen from here. So we will get HCl, and the remaining part will be C6H13 and dot. Why C6H13? Because one hydrogen is taken by this chlorine. It is a free radical, so it is more reactive. So C6H13 and the free radical will react with molecular chlorine. This is more reactive, so it will snatch one chlorine from here, and we will get C6H13Cl plus chlorine free radical. In the termination step, we have to write, even here one step is enough because we need to reach here. So C6H13 free radical will combine with C6H13 free radical, and when they join together, we will get C12 and H26, which is our product. Question number 5, like this question is about again fuel and polymer. Now, in this case, used coffee grounds have been suggested as a carbon neutral fuel to replace some fossil fuels. Explain why coffee grounds might be considered a carbon neutral fuel. Any fuel which comes from the plants, like means biofuel, it is considered carbon neutral fuel. The reason is whatever the carbon dioxide it gives to the air on combustion is equal to the amount of carbon dioxide it absorbed during the photosynthesis process when it was in the plant life. So this is like me the fuel which is taken from the coffee grounds. So the fuel releases, you can say emits the same amount of carbon dioxide on combustion. This is the first part for 1 mark. Then that it absorbed from the air during photosynthesis. Second mark. Explain how the use of fossil fuels causes climatic change. So definitely fossil fuels actually they are from millions years ago from the fossil. So on combustion, fossil fuel gives carbon dioxide gas into the air. Now, what will be the effect? In carbon dioxide gas causes global warming or increase the temperature of the globe. Increase the temperature of the globe. Long chain alkanes are not normally used as fuel because they don't burn efficiently and they give more knocking as the product soot. They produce soot. Soot means pure carbon. Name another pollutant from incomplete combustion. Now, my dear student, keep in mind in the complete combustion, always carbon dioxide and water is produced, while in the incomplete combustion, we get either carbon monoxide and water or carbon and water. But here they made it very clear that carbon soot, this is carbon soot. Name another pollutant. So it means they are not interested in this one, they are interested in this one. So another pollutant is carbon monoxide. Write the equation for the complete combustion of octane. So C8H18, this is combustion, so plus O2. And complete combustion, so always carbon dioxide and water. We have to balance the equation, so this is 8, this is 8. Hydrogen 18, so 9 times 2, 18. Now let's come to oxygen balancing. So this is 16 plus 9 times 1, 9. Total is 25. So look at here. If you write this 25 here, so 25 times 2, 50. This side is 25. This side is now 50, but divide by 2. So you'll get 25 both sides. Or instead of this 25 over 2, you can write 12.5. They allow this also. So in such question, you should give more you should be more focused to get maximum marks, not to lose a single mark. Long chain alkanes are converted into smaller chain. This is long chain alkanes are converted into smaller chain alkane, which are more useful molecules, including alkene as well. And in the process is cracking, in which the long chain alkenes are converted into short chain alkene. In the upper atmosphere, ozone can react with halogens and with halogen-containing compounds such as molecule X. Name the molecule X. Now, we will select the longest continuous carbon chain. There are two carbons only. We will number the chain from that side to which the branches are more. So this is chlorine, chlorine, and chlorine. So on first position, there are two chlorine, and second position, there is one chlorine. So the name will be 1, 1, and 2. Then dash trichloroethane. The next question is part B. The CCl bond undergoes homolytic bond fission in the upper atmosphere. State the essential condition necessary for this process. So it is UV light, ultraviolet light. You can say UV light, ultraviolet light. If you forget this one, you can simply write sunlight. They allow this answer as well. Now, write an equation for this fission reaction in a molecule X. In the molecule X, this molecule X include curly half arrows. So see here, we have to write this structure first. So C and C, this is H, this is H, this is chlorine, chlorine, this is chlorine, and this is H. Now, to write its fission reaction in the molecule X, definitely the CCl bond will be broken down. So see here, and this is homolytic fission. So what we will do, and we have to show the curly arrow. So carbon, chlorine, either this one or this one or this one, any bond you can take. From the center of the bond, you will draw a curly half arrow here and another curly half arrow to carbon. And what will be the product? The product will be two free radicals. The rest of the atoms will not change their position. So this is one and plus chlorine one. And we will get the two free radicals after the homolytic bond breaking. Now, write an equation for the reaction of chlorine free radical with the molecule X. Now, the molecule X this was H, and this is chlorine, and here it was chlorine, chlorine, and this is H plus this. The chlorine free radical with the molecule X. Now, as I told you before, chlorine free radical is highly reactive. It will snatch one hydrogen from here. So what will form? HCl will form, and plus the thing which will remain, and this is free radical. So this is easy question. If your concept is clear, so follow it and write the correct answer. Part 4, write an equation using displayed formulae for a free radical form in the sequence to give a molecule with a formula C4H4Cl6. Now look at here, this free radical, suppose you form here, you can copy this one, no problem. This is one free radical, and another free radical will be also same like this. But write the free radical, this is like we just turn the compound by 180, just the two free radicals should face to face each other because they will make bond between them. So there will be now 4 carbon in the chain, like 1, 2, 3, 4. Now here chlorine and 2 hydrogen are bonded, and here chlorine and 2 hydrogen are bonded. While here is chlorine, chlorine, and here is chlorine, chlorine. Okay. The next part is state the type of reaction occurring in B4 and B4 and the name of the product with the formula C4H4Cl6. So here you see the two free radicals joined together to give a neutral molecule. So this is termination step. In termination step, always two free radicals will join together. Now the name, let's come to the name. So the name is, you'll start numbering either from this side or that side. It makes no difference. So 1, 2, 3, 4. Now one chlorine here, one here, one here, one here. Just encircle it that it should not, you should not left any chlorine. This attach at one position, then 2 and 2, 3 and 3 and 4. So you can write the name 1, 2, 2, 3, 3 and 4. Total 6 chlorine. So dash hexachloro butane. The straight chain is to 4 carbon. Hexachlorobutane. Maybe like they will take, or you can take another free radical, but the free radical must have this, because if you look at here, this compound uh, gave the formula C4H4Cl6. So the two free radical must be in a way which can give you this formula, where carbons are 4, hydrogens are 4, and chlorine are 6. So maybe you can take the free radical which are different from these two. In that case, the product will be definitely different and the name will be different. So in that case, also your answer will be correct. Question 7. This question is about hydrocarbon obtained from crude oil. Petrol used in cars has a high proportion of alkane isooctane. Isooctane can be formed by heating octane at 400 degrees centigrade in the presence of catalyst. Now they are asking, this is the octane straight chain and this is isooctane. Now isooctane is its common name. Its IUPAC system name is not this one, and they're asking for the IUPAC name of the isooctane. So see here, you will number the chain. First of all, you have to select the chains 1, 2, 3, 4. And you can go up, you can go here, no problem. So the longest carbon chain is having 5 carbon. Now, why we number from this side? The reason is that this is a branch, this is a branch, and this is the branch. I told you that we have to number the chain in such a way that the branches should get least number. So 2, 2, 4. So 2, 2 and 4, trimethyl and pentane. Isooctane, it's a branched chain octane. Its name is also called ideal fuel. Ideal fuel, perfect fuel, its octane number is 100. Okay? It burns very efficiently, produce zero knocking when burned in the engine. Name the industrial process used to convert octane into isooctane. So any process in which the straight chain change into branch chain or cyclochain is called reforming. You have a reason why petrol needs a high proportion of isooctane. Now this type question is coming again and again. So petrol should burn, or petrol will burn efficiently. You can write this, or you can also write that to prevent knocking produced in the engine, to increase the octane number. You can also do like that to increase the octane number. So any option you can write for 1 mark, but keep in mind these marks, okay, these points. Question 8, you can see the long chain. This question is about the production of squalane, a liquid alkane which occurs naturally in human skin, and along with that, and is used in cosmetics. I always tell the student that whenever you are doing the practice in the past papers, to read the question more carefully, you have to learn, you have to get the knowledge from the question. So see here, this is alkane, the long chain alkane produced in the human skin, and as well as it is used in cosmetics. Suggest two properties that make squalane useful in cosmetics. So it has many options. It has many options because like the question is very open question, but always write the as you want. As I told you, alkane is saturated. Saturated means each carbon is making 4 single bonds are attached to 4 atoms, so it is least reactive. So you can say here that when it is used in the cosmetic, definitely we will put the cosmetics on the face, our hands, on the skin, so it is unreactive. So it will not react with our skin, so there will be no allergy problem. Second thing is this is alkane kind of oil. You see that sometimes the skin gets oily, so it is hydrophobic. Hydrophobic, it means it does not dissolve in water. You can write other option like it is colorless or it doesn't give smell. So, but these two options were easy option. Okay, the molecular formula of squalane. So this is alkane. Alkane general formula is CnH2n plus 2. So just count the number of carbon atoms, but be careful, you don't rush 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Total are 30 carbon. So if carbon is 30, so hydrogen will be 2 more than its double. So the double of 30 is 60. So 60 plus 2 will be 62. It's an easy question. Alkanes, question 9. Alkanes and alkenes are obtained from the crude oil. Describe how a sample of octadecane can be obtained from a mixture of alkanes. This is like the mixture of alkanes is separated by the process called fractional distillation. You study this topic in IGs as well. But for 2 months, how you will write it? So number one, that the mixture of alkane is heated strongly to vaporize it. And then the vapors of each fraction are condensed in the fractionating column according to their own boiling points. You know that the fraction which has the lowest boiling point will reach to the top of the column, while the fraction having the higher boiling point will stay near the bottom. So 2 marks, so briefly you can write that. Octadecane can be cracked to produce butene and one of the other product. Complete the equation, state symbols are not required. So look at here in cracking process, this is very simple. This is carbon is 18 and here 4 times 2, 8. So 18 minus 8, so how many carbon left? 10 carbon left. And after that hydrogen, so 8 times 2, 16. Now 36 minus 16. So the number of carbon left were 16 and 38, sorry, 38. And this is 2 and this is 2, so hydrogen is 22. So you will get the answer of your question. Part 2, one of the products of this cracking reaction is but1-ene. Although this is alkene part question, but anyhow, like it is here, so give a skeletal formula for the other 3 alkene isomers of C4H8. Be careful, cracking reaction but1-ene, and they're asking skeletal formula. So see here, one of the products of this cracking reaction is but1-ene. So one is this one. And they are asking that other 3 alkanes. So read the question carefully. You cannot include this answer over here. So you can write your answer like this. Now this is 1, 2, 3, and 4. Secondly, you can write your answer like this. This is also 1, 2, 3, and 4. And then you can remove one carbon and then attach as a branch. Now, what is the difference between this and this? This I will explain in the alkene topic, but here, double bond here, second position, second position. So the name in both case is but2-ene. And this one is also but2-ene. Names are not required here, but actually I'm explaining just to give you the idea. Here, the bulky groups are on the same side. So it is called cis isomer, you can say, cis but2-ene or Z but2-ene. And in this case, they are on opposite side. So it is called trans isomer. So trans butene or E-but2. And this is a branch. Question 10, the structure of a compound X is shown. X is present in petrol. Again, this is, if you remember, this is the same thing like, but in other form, 1, 2, 3, 4, and 5. 2, 2, 4, trimethyl pentane. If you remember in the previous question, we said isooctane. Now, octane. So let's look at here. Calculate the carbon atom 1, 2, 3, 4, 5, 6, 7, 8. So they are asking the molecular formula so far 1 mark. So C8 and hydrogen will be 2 more than double. So double of 8 is 16 plus 2, 18. So this is the molecular formula. Name the industrial process used to produce X from the straight chain isomer, and this is called reforming. When we are producing the branched alkane from the straight one, it is called reforming. Heptane is also present in petrol. Write an equation for the complete combustion of heptane. Heptane, so C7 and H16 plus O2, and it will give complete combustion. They go bold, carbon dioxide and water. Carbons are 7, hydrogens are 16. Now look at here, 7 times 2, 14 plus 8, so 22. And you can easily write here 11. 11 times 2, 22. Part 2, identify by name or formula a pollutant that may result from the incomplete combustion of heptane. So either you can write name or formula. So write the formula, CO, carbon monoxide. Better to write the name because sometime if you suppose write this one, so the O small, so this will present cobalt and maybe you will lose the mark. So I will suggest that if you have time, so better to write carbon monoxide. So name is much better than the other minor thing, but in ACE level, they are serious. So that's why you have to take care to get full. In part C, recently sales of electric cars have increased. Give two environmental benefits of using electric cars. Justify your answer. So is electric car use electricity which comes from the renewable resources, like suppose from hydro powered electric stations. So you can say that electric cars, they do not release or emit carbon dioxide gas, so reduce global warming. And second point, it does not give oxides of nitrogen and sulfur, so does not produce acid rain. So these 2 points are uh, from the environmental point of view, and they give environmental benefits instead of using the fossil fuels. Dear students, these were some questions from the alkane section B part. If you like the video, so I'm requesting you to subscribe the channel. Thank you.